Hey guys, we are still in lesson 3.1, but today we're actually going to get into graphing. So we're going to call this graphing equations, and we're going to show you two different ways to do it. Graphing equations, let's see if I can spell. Graphing equations, I don't know where that came from. Using, that's where it came from, intercepts, so that's one way. Or table of values. Okay, so let's talk about graphing using intercepts. That'll be our first one. Now, this has a little bit of a disadvantage, intercepts, because all it takes to draw a line are 2 points. And if you can identify what the X-intercept and Y-intercepts are, which we talked about in the other set of notes, then it's going to be, you can graph those 2 points. But if you made a math mistake, you won't know because you've graphed 2 points and it creates a straight line. So that's the disadvantage of using this strategy. Okay, so first things first, we're going to determine the X and Y intercepts of the equation. Now I'm going to tell you the easiest way to find the X and Y intercepts is if your equation's written in standard form. Okay, so that's going to be number one. And we're going to talk again as we get into the examples what to look for those intercepts. So once you've figured out what those 2 points are, you're going to graph these 2 ordered pairs. Okay, and then we are definitely going to connect them to create a line. So connect the points using arrow caps, so we know it goes on forever. And for whatever reason, I have some students who just draw segments. That's not going to work for this. It's a line, so it's going to continue infinitely in either direction, and the arrow caps let me know that. Okay, so that's basically it. So we're going to get a set of directions that say graph using intercepts only. Okay, so we're going to do one example, and then we're going to talk about different strategies there. So we've got put it in standard form. Now I'm going to tell you not all the problems in your book are in standard form, so that's what you need to make sure you do. Now, here's the good news. This one is in standard form. Yay! So that's one less step for you to do. But in the book, that may not be the case, so you're going to have to, again, put it in AX plus BY equals C form. Okay, so let's talk about an X-intercept. So if you remember generically, we're going to get an X value and 0 for the Y value because it sits on the X-axis, so it doesn't go above or below the origin. So what we're going to do is take our equation, and where we see Y, we're going to substitute in 0. Now, I've heard that the high school calls this the thumb method, and so they cover up the term that has the 0 in it, and then they just solve what's left behind. So in other words, we're going to solve 2x equals 16. Divide both sides by 2, and we get x equals 8. So that's going to be the first order pair we're going to graph is 8, 0. So then let's do the Y-intercept. And remember, that's going to have a x value of 0 because it doesn't go to the right or the left of the origin because it's sitting on the y-axis, and it has a y value. So on this one, we're going to get 2 times 0, and then plus 4y equals 16. So the thumb would cover up the 2, 0, leaving just 4y equals 16. And then we do inverse operations, and we get y equals 4. So we're going to graph the ordered pair 0, 4. All right, so you guys are going to be using graph paper, and you're going to use the lines of the graph paper to mark your tick marks. You're also going to be using the lines of your graph paper to put the dots. And if you don't use the lines of your graph paper, then your graph is pretty meaningless. It's the whole point to having graph paper. So we got to label x-axis and y-axis. So I'm going to write down these things that you should have every graph. So you're going to label x and y-axis. I'll say axes, that's the plural of axis. Now on, let's say I had graph paper. I guess I could pop some up. Let's see if I can pop some up. I think, yeah, there we go. Okay, pop some up, and I'm going to rearrange, I'm going to redraw this. So it's on the lines of the graph paper. It'll make things a lot easier. Now, not always do I draw a graph that looks symmetrical, because sometimes the points I need, let's see, 1, 2, 3, 4, 5, 6, 7, 8, perfect. That's all I really need, okay? It's the points that I need. I don't need the negatives because I have 2 positive numbers that I'm going to be graphing. So the second thing I'm going to do on my graph is to mark tick marks on the axes. For some reason, students like to just do numbers, but we need to actually tell where the locations are. And then I would label every other one, because if you label all of them, especially if your graph is kind of smaller, then it's going to be messy. Now, you can have the intervals, the spacing between each tick mark, count for different numbers. So I'm doing each tick mark counting by 1, but sometimes you could make each tick mark count as a half. So it just kind of depends what you want to do. But I'm just going to do it just a couple of these. So again, every other number, the evens. Okay? And so this is something I look for because I see a lot of times kids have uneven spacing, and that actually messes up your graph, the accuracy of it. Okay. So then that's the next thing we did, is we labeled the tick marks, or let's say label, let's do a pause. Label tick marks, and then every other one, and then I would recommend the evens, because if you do the odds, you're skipping 1 space to do 1, and then 2 spaces to do 3, and 2 spaces to do 5, and so on and so forth. Now I'm going to go ahead and mark the points. So graph the points. In this case, well, I'll just say points, but in our case, it will be the intercepts. Okay, so let's see, we've got 8, 0. That's our X-intercept, and 0, 4. That's our Y-intercept. Now this is when you guys should be using a ruler, so I'm going to write that down. use a ruler. We have an activity we'll do later in the chapter where if you don't use a ruler, it may not work out to get you the right answer. Straight edge. So all a straight edge is a ruler without numbers on it. Yeah. To draw the line. Okay. So I'm going to see. I'm usually pretty good about eyeballing things. Okay? And those aren't very pretty, but you got to make sure that you have arrow caps on your line. So I'm just going to say arrow caps. And that's what your graphs should look like. And if you aren't going to number the tick marks, if you aren't going to make the tick marks, if you're not going to use the graph paper, if you aren't going to label X and Y axes, if you aren't going to draw a line with arrow caps, expect to not get full credit. Okay? All right. Now, we have a couple of special graphs. So I'm going to write them here at the bottom. So if we have X equals a number, so you don't see a Y, you only see an X, then what we have is a vertical line, line through X equals 3. So vertical looks like this. Now, if you have Y by itself and then equals to a number, you're going to get a horizontal line through Y equals -2. So it's going to look like this. So what's weird is that Y equals is a line that looks like the x-axis. And X equals is a line that looks like it's the y-axis. Kind of strange, huh? All right, let's go on and let's talk about the other strategy. Let's talk about how to graph. I'm going to take the graph paper off for right now, and then I'll add it back when we graph. So graph using a table of values. So again, what's good about this guy is that it's more accurate. You have 3 points. If the 3 points don't form a line, then that means somewhere you made a mistake and you got to go back and check your math again, okay? So we're going to solve the equation. So that Y is alone on the left. Alone on the left. Now we're going to talk about this equation later on and give it a specific name. But for our purposes, we just want to solve it that way. It's going to be far easier to do the math if we first get the Y alone. And then we're going to select 3 values for X. So remember we talked about in chapter 1, independent variables are the ones we choose. Dependent variables are dependent upon what we chose for our X. So our Y values are dependent. And I'm going to tell you my 3 favorites are, and I like them because the fact that they are small and I'm less likely to make mistakes. I always choose 0, and then I like to choose +1 and -1. Now, you're not limited to those, but I would highly recommend you have 1 positive, 1 negative, and the 0. The smaller the numbers, the better, okay? So those are my preferences. You can choose whatever 3 you want. Then you're going to substitute the x values into the equation, the one that we've translated so that the y is by itself. And solve for y. Okay, and then we'll have two coordinates that we'll put together and will form an ordered pair. So we need to get 3 of these ordered pairs. Okay, and then we're going to plot the 3 points. Then connect in a line. Okay, so linear equation, right? So directions are going to say graph using a table of values. Now I am going to demonstrate with the exception, if I have a coefficient in front of my x, which we're going to have in our first equation, I'm not going to choose my 0, 1, and -1. I'm going to choose whatever the denominator is, and you'll see that in this very first one. So this is our example 2, and it's already got y by itself, and we get y equals 1/3 x plus 2. So this is what I do. My table is going to have x, I'm going to choose, and then I put in the equation because that's where I'm going to do my calculation. Output is a y, and put them together, oh, that's a terrible y, as an ordered pair. Now, because I have coefficient that is a fraction, that's going to alter my choices. So I'm going to choose a 3, I'm going to choose 0 always, and I'm going to choose a -3. That way I will not get fractional answers. It's a pain in the behind to graph fractional answers because you're always kind of guesstimating where it's located. Alright, so here we go. Y equals 1/3 times 3 plus 2. So I just do the math. 1/3 times 3 is 1. 1 plus 2 is 3. So my ordered pair that we're going to graph is 3 input, 3 output. Okay? Alright, let's try it again. This time we're going to substitute in, sorry, it's supposed to be a 3. A 0 for the x. So I get 0 plus 2 equals 2. So the ordered pair I'm going to graph is 0, 2. Now that would be considered the Y-intercept because I ended up with 0 for my x coordinate. And then the last one, I'm going to have 1/3 times -3 plus 2. So I get a -1 plus 2 equals 1. So the last one I'm going to graph is a -3, 1. So I'm going to bring back my graph paper. Now this one I've got positive x's, negative x's, but I do have all positive y's. So that's going to change my graph from what I had before. So y and x are labeled. Make marks at the tick marks. Label every other number. All my x's were positive. Okay, and then I'm going to start graphing those 3 ordered pairs. So 3, 3, 0, 2, negative 3, 1. And then I'm going to connect them up. And arrow caps. Okay, awesome. So I'm going to go ahead and take off my graph paper for the moment. And then we're going to go ahead and do our second example. And this one on this side is going to create a little bit more work for us because it's in standard form. And we need to get it so that y is alone. And again, I'm sure some of you already know what that's called. So let's see, we're going to get rid of the x by doing inverse operations. This is why we also practice transforming formulas or literal equations, because that ends up happening here. Divide everything by negative 1, and we get y equals a positive 2x minus a 2. Okay, so to not lose room for my graph, I'm actually going to do my table to the right. So we start with x, we write y equals 2x minus 2. Now the other issue we might run into, obviously, is making a calculation error when we are transforming our formula, or transforming our equation, and that could end up getting the wrong graph as well. So, this one's good, so I'm going to choose my 3 favorite numbers. I'm going to choose 1, 0, and negative 1. So then I'm just going to solve for each of these. Y equals 2 times 1 minus 2. So let's see, we get 2 times 1 is 2, minus 2 equals 0. So my first ordered pair is 1, 0. Which is the X-intercept, because I have an X value and Y for the 0. The second one, we get Y equals 2 times 0 minus 2. Oops, sorry, that should still be black. I don't know why I did that. And then let's see, we get 0 take away 2 equals negative 2. So our second ordered pair is going to be the Y-intercept because it starts with 0 in the X. And then last but not least, we're going to do negative 1 for X. We're going to get negative 2 take away 2. Signs are the same, so I add and I get a negative 4. So that ordered pair is going to be negative 1, negative 4. All right, so this one's pretty interesting. I've got negative y's, and I have positive and negative x's. So I'm going to bring back my graph paper. And I may do things a little differently this time. I need a lot more. Oops, that line's not where I want it to be. Okay, so I think what I'm going to do is to use 2 boxes to count for 1. Yeah. Notice I have arrow caps on all my axes. Label X and Y. Tick marks are on the lines of the graph paper. I have 2, negative 2, negative 2, negative 4. Okay. So let's start graphing. So I have 1, 0. So that puts that on the x-axis. I have 0, negative 2. That puts that on the y-axis. And then I have negative 1, negative 4. So they all do seem to form a line, and then all I do is connect them up. And that's it. All right, good luck with this, guys. Bye now.